Welcome, everyone, to our very first AI Insights live stream here at Domo. My name is Eddie Small, and I will be your MC, host. I don't know what I usually call them on these things, but the guy that's going to kind of switch the cameras and all the buttons and the presentations, because the smart people will be the ones talking to you today, and that's our folks from the Domo AI Labs team. Florencia, Shelby, and Christy, welcome, 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 and a very special guest, John Lee. You know him.
Finally.
You know him as Dashboard Dudes, right? You know him as the Dashboard Dudes. Really appreciate you guys coming on. We obviously have a lot of parts to this AI Insight series, this AI Readiness Initiative, essentially what we're trying to accomplish here as far as bringing in some of the stuff that you guys are learning through the AI journey, some of the stuff that you want to let our customers know about. Obviously, the Domo AI Labs team is a force when it comes to all of the practical things that you can do with AI. And today we're going to talk a lot about data cleanliness, showcase some best practices, some stuff that we're doing here at Domo, but also having John on to also give his insights on Domo as a platform and tools when it comes to AI. Lots of exciting things happen. You will see my good friend, Sean, our social media director on LinkedIn. He says, hi, everyone. Welcome. Thanks for joining today. And I don't know how he does it. He's either here or he's on YouTube or he's commenting. But the other Dashboard Dude, or there's just one, right?
I'm moving so fast that you can't see that I'm in two separate places at the same time. It's like the Flash.
Because your ways.
There's two of you. I'm convinced. We also have our good friend Davis Vishaka, Brian with an I and Brian with a Y, as I like to call them, Brian Squared, in the background, ready to answer any questions that you might have during the live stream. But I'll get out of the way like I normally do and hand it over to Christy Raleigh. Christy, thank you for you and your team to jumping on and letting us know a little bit about what you're working on in the AI Labs team, and specifically AI and data quality.
Thanks, Eddie. We're super excited to be here. We'll kick this off. Flo will set us up with our screen share there. And as she does that, I want to just give everyone a gentle introduction to my team. So there are a whole bunch of teams at Domo. We do a whole bunch of different things. And a lot of us are working on AI. I dare say that almost everybody's working on AI in some fashion. So my team at the AI Labs team, we have a threefold mission. The first one is we work on product development. So anywhere where we want to integrate machine learning into the product, my team is working on that. We also we're a consulting team. So we build custom solutions, custom AI solutions and ML solutions for customers. That's probably where you've heard about a lot of the things that we do at Domopalooza. We were there talking about some of the use cases we've done with customers. Our customers share the stage with us to do that. So that's another thing that we do. And the last thing that we do is we build ML and AI for Domo that we use to run our business as well. But there are lots of teams at Domo working on AI. So we have this series and we want to get a whole bunch of different points of view on AI, because we know we've got lots of different perspectives out there and we want to give you the best of all the world. So we're not going to hog the seminar series. We are going to share the love, and lots of people at Domo are going to talk to you about AI. This is a series of 6 webinars, so we can talk about what those are. They're posted here on the screen. You can take a look. Please come. We are striving to hit all audiences. So we want to include information for business users, for analysts, for data scientists, and for advanced pipeline experts. So we're going to cover things that will be useful to all of those groups in each of the webinars. So there's not necessarily any one target audience for any given webinar. We're trying to make it applicable to all people that can come and share some insights with us. That also means that we're going to dive deep sometimes. So if some of it's a little deep for you, that's cool. You can tune out during that part. That's all right. Or you can learn some more stuff and reach out to us too. We'll show you at the end that we've got some free office hour options for you. If you ever want to learn more, you can reach out to my team and we can set those up. So with that, mark your calendar, get the series on your calendar. You can hear about AI from a lot of different perspectives. And today we are going to talk about AI and data quality. I'm going to let everybody introduce themselves first. As Eddie said, I'm the Senior Director of Domo's AI Labs team. That's all you need to know about me. Let's go to John next for an introduction.
Hello, hello, hello. My name is John Lee. I'm from Dashboard Dudes, if you've seen me. One of the fun stories I just want to say real fast is I had the pleasure of having Chrissy joining me on stage when I made spring rolls with Eddie, who was also here, John Miller, and Noah. And my favorite part was she was like the best one out of everybody. The best one, Chrissy. And then I loved when I saw the corner of my eye, said a joke, and I just saw her do this. And I'm like, cool, I'm winning. I'm doing well in life right now.
I'll be doing that a lot today. There we go.
That's me.
Shelby, let's go to you next.
Hi, my name's Shelby. I've been a data scientist here on the Domo AI Labs team for about 2 years. I really enjoy working with customers. I presented a project that I worked on with Boyne Resorts at Domopalooza, if I look familiar. Yeah, and I really like sharing data science best practices, and I'm excited to be here today to do that with Flo.
Awesome. Thank you, Shelby and everyone. My name's Flo. I am a data scientist, as you probably know from seeing this slide, on Domo's AI Labs team. I have been at Domo for about 3 years, and I absolutely love data science and working with customers and developing product. And I'm just really excited to be here and to talk about something that I feel like I've been so passionate about for so long, and people want to hear about it. So that's my nerdy intro.
So we're so excited to have you all here today. And with that, I'm going to send it right on over to John Lee to kick us off.
All right. I'll share my screen in 1 second, but I want to address, as Chrissy was saying, we have a broad range of audience people, and I want to address some of the business people who are probably not sure what a data scientist is and how that's different from an analyst. And I want to talk about this because I've seen situations where I've had people who are like, oh, yeah, we just got a data scientist. And they have the data scientist finding averages of things. And it's like, that's not their job. Their job is really to do like machine learning stuff, regression stuff, modeling stuff, not really tell me which one was more of something else. That would be more like an analyst to find you averages and how much revenue you produce, all that stuff. If it's anything like predicting, well, that you would then start to go into the world of data science. And I want to show you this. So I will share my screen now. 1 minute. We'll do this one. Okay, let's see. Awesome. So I had a client one time who was like, "Hey, we wanna try this data science thing." And I'm like, "Sure, let's go do it." And I said, "Give me as much data as you have on whatever we're trying to find." And they're like, "Cool, great, great. We have a lot of data though." I'm like, "Sure. So tell me what that means." And they sent me a file that looked just like this, an Excel file. It looked exactly like this. They had a lot of data, 10,000 rows. And for Flo and Shelby and Christy, they're laughing at that. Yeah, yeah, exactly. 10,000, that's nothing. Grain of sand. But they're like, we have a lot of data. And when I saw it this way, I said, okay, we got a problem already just off the bat. There's a lot of things wrong with this. So this is kind of like a Where's Waldo? Can you find what's not so good about data like this? We have some revenue numbers by division by month. I'll show you some of the ones that I called out to them. Let me do here. Oh, first one is this one, merge cells. So a lot of business people have a tendency to do things in Excel that they think make it cleaner, but are actually not good for actual data processing. And one is merging cells like this. It makes it very hard because now we have columns that are all clumped together. Like, I don't know what's happening. We need it to be a CSV file usually or a text file. So that's the first one. They had merge cells. Second one was this. This is a common one I see all the time. Again, I'm an Excel guru. I'm extremely good at Excel, but people put dates like this, where you have the dates listed as columns. This makes it extremely difficult because they're their own columns. You want to have more infinite rows and infinite columns. So you want to have dates all the way down, if you can, by day, because we can always go from smaller to bigger instead of taking something bigger and making assumptions to break it down. There's one more in here that I would be extremely surprised if anybody could find it. I'll give like 10 seconds to see if you can figure out what else is wrong with this thing. No actual dates. True. I'm going to show you this other one, and you're going to be like, what? That little sucker right there. 37, comma, space, 740. This is exactly what happened with this file too. Somebody manually put something in there and there was a space. This little thing, I set this at my Domopalooza presentation. If you add a drop of water to chocolate, it's called blooming. It makes the whole thing start to be clumpy. Same thing, if you add a space where it's not supposed to be, if you add a character where it's not supposed to be in a numeric column, the whole thing now is a text, not a numeric. And I had to find this by putting in a Domo, and I was like, wait, why is this thing blue? Why is it not green like numbers? I was like, oh, somebody put that in here. So this is an example of, these three are examples of what bad data looks like. So if you're trying to be like, hey, we want to get a data scientist in place, first let's talk about the data you have, and is your data clean? Is it ready to go? I'll give another example here. Sure. I say data is a lot like cooking. And in my mind, how it works is an analyst is your prep cook, they're your line cook. They're there to chop, they're there to cut, to prep stuff, get it ready to go. All right. Yeah. Your data scientist is your pastry chef. And what I mean by this is, in a kitchen, if you ever worked in a kitchen, in culinary school, there are two tracks. You're either pastry chef or you're everything else, because they're so different. And in the kitchen, you have usually one pastry chef. And you don't, like a data scientist, you don't need a lot of them. But for the ones you have, they need to be very, very good. And what you can do is you could take the line cook and you could make them cut things for the pastry chef, and you could take the pastry chef and put them on the line, sure. But it's very difficult if you're like, hey, I want my line cook to now make me a very, very decadent dessert. They just don't have the skills to do that. So that's what I said. You can move it on there. So we need to make sure that our data scientists are good and that they're consistently very good. Here's just one more example. Flo over here, if you didn't know, she's a secret pastry chef, actually. And she made those strawberry lemon macaroons on the right. So for instance, if I was a line cook, I could do all these things. I could wash some strawberries for her. I could core them out for her. I can cut them for her. But she can then use them for whatever she needs to use them for macaroons. It'd be very different if it was like, hey, John, go make these macaroons, which I have no experience doing. But she can always cut and prep the ingredients for us if we need to have it. So this is my kind of analogy, what I've seen. And my thing is, like, for the business people out there, if you are considering getting a data scientist, I think first you need to really ask like all these other questions. Do you have data that's clean? Do you know what they're doing? Are you having a data scientist do what a data scientist is supposed to do, not what an analyst is supposed to do? And lastly, are you serving up the ingredients correctly for your data scientists to have enough of it so that they can do their job correctly? Those are my big things. If you ever want to talk more, I'm happy to talk more about it. Cool. That's me. I'll give it back to Flo.
Awesome. Thank you. I tried to make macarons again last week in preparation for this webinar, and I hadn't made them in a year and I failed miserably. So that picture is from a little bit ago.
You're back on the line. You're back on the line until you
I'm
prove
back
yourself.
on the line. I gotta make my way up again. So just, I'll keep practicing. All right, so I'm gonna get my screen shared here. So some of you might have heard about this checklist before, especially if you were at the AI readiness session at Domopalooza, or if you've interacted with our team. We've had some version of this checklist for a long time in the data science team. It's been around for as long as I've been at Domo, and I think I remember seeing a version from about 5 years ago. So it's not a new asset for our team. And really, the content of the checklist is not new concepts, right? It's really just, it condenses a lot of years of academic training into a high level checklist that hopefully a majority of people can process and understand. And The original intent of the checklist was for internal use, right? It was a way to ensure that our team was being very thorough when preparing customer or internal data. It's items to look out for when we are validating a data set before we dive into analysis. Full transparency, I don't think anyone on our team pulls out this checklist every day. I think we have done this so much that it's all ingrained in us and we know it by heart. But even though we're not using it as frequently as, someone who's not a data scientist might want to use it, we've been working on this checklist and improving this checklist and making updates to the checklist. And that's because as part of the education that we provide during our engagements with customers, it's very common to get a request for, hey, can you give us some tips on how to get our data ready? If we want to replicate what you're doing as a data science team, how can we get started? And that has been a lot of the reason why we've continued to improve this checklist and why we're wanting to share it with you, right? And then generative AI became a thing, right? And it was an explosion in history. And as data scientists, we've always cared about data hygiene. We are very passionate about it. You can talk to any of us, and you will come to find out that we are, we could be here for 48 hours and I would still be really excited to tell you more about data science, data cleanliness. But everyone cares about clean data now because clean data is so important for generative AI. And so we're sharing it with you. We're going to go over some of the key pitfalls today in detail. And as you go through this list that will be shared with you, as Sean pointed out, some of the items on the list might seem a little silly, or it might feel like they are just really not that big of a deal, but they are. They can have a massive impact down the line. If the example that John just gave, right, of, you have that little space in between your values, that can throw off how a column is transformed, how it's interpreted, how it's processed, and that can throw off any model, any prediction that you build later on. So being really mindful of these things is imperative to have a successful AI experience. And you'll also notice that the checklist is actually not comprehensive, right? The list is pretty universal. It will get you about 80%, and I'm throwing that out there, don't quote me on that, say 80% of where you need to be to use your data for AI. But the last 20% is very use case dependent or AI tool dependent. And so what we're showing today are best practices for getting your data most of the way there. Would anyone say that's fair? Disagreement? Agreement? Thumbs up from Christy. It's the validation I needed. All right. So let's go and talk about how this kind of takes a little bit of time. Shelby, do you want to tell us about that?
Yeah, totally. So, like I said, the checklist will be shared after this webinar, but as a spoiler, there's about 30 rows of advice or checklist items for you to go through as part of AI readiness. And I don't know about you, but I get overwhelmed sometimes just looking at it like, whoa, so one of these things could take me a while. And I don't want people to get overwhelmed when they see it. On the bright side, you should have done at least a couple of them already with data sets that you're wanting to use. So good job, yay. But there's going to be stuff that you haven't done. And what we want to emphasize is that this just takes time to do all of these different items. On the screen here, you'll see a data science solution timeline. We have different phases that we go through when we do client solutions. And if you can tell, the very first bar says prepare, and it's by and far the longest line on that chart. And that's because the prepare phase is typically our longest phase by far. I think that one, this client, it took 5 out of the 8 months to do data cleaning. And I'm not saying it's going to take that long for everyone, but I just want to show a realistic example of like, this takes time if you want to do it well. That being said, I don't want people to never do AI because they get overwhelmed and they're like, I don't have 5 months to clean a data set. Like, The goal here is do what you can given the time and resources that you have and move forward. Data science is a process. You can always come back. You can always do better with your data. So just get started somewhere. And if you have time, spend at least a little of it doing some of the things that we're about to talk through. So with that lead in, we want to talk about the 5 most common pitfalls that we see from our checklist. And Flo's got those listed here on the screen. We're going to be talking in depth about each of these. And we specifically want you guys to walk away knowing 3 different things. What is the pitfall? Why should you care about it? And what should you do about it if you have this problem with your data? We'll be showing some of these pitfalls with sample data, so you can see like a real life example of like, what does this look like in a data set? So hopefully that's helpful. I know I'll be sharing like a sample HR data set. So with that, I will dive in. Let me share my screen really fast. Okay, let me know if you are not seeing the 5 common pitfalls screen anymore. I'm just going to keep going. So the first pitfall you'll see here is the sample in your data set is not aligned with your use case. This is probably the first pitfall that our team always tackles when we start a data science engagement. And this issue is what it sounds like. It's that you don't have the right rows in your data set for your use case. And I'm not talking about something like you want to know something about sales and you're using a marketing data set. What I'm talking about is having some of the right rows and maybe some of the wrong rows and maybe missing other rows entirely. So to give a concrete example of what I'm talking about, this is my HR data set. And I've got 1 row per employee in my fictitious company. And all of the columns are HR related stuff like whether somebody's been terminated or not, what department, what job role, things about their pay, performance, education, etc. And so as an example, we'll frequently get asked to do something like, we want to predict employee turnover. And they'll hand me a data set that looks just like this. And I'll say, okay, so it looks like you've got the status of the employee here. Some of them are active, that's what A stands for, and some of them are terminated. What I don't see is a column that tells me why someone was terminated. Presumably at your company, some people were terminated involuntarily, and some people voluntarily just left. And I'm assuming you probably want to focus on one of those types of turnover. So we can't have both of those groups of people in here. Another example would be if I look at your termination year and I see that it looks like you only have people who have terminated between 2018 and 2020. If your company has been around longer than 2018, there should be more people here. Where are those people? The last one is like, look at job role. There's a bunch of different job roles here. And I see you've got some managers, you've got some directors. Like, are you wanting to focus on like managers and directors or just rank and file employees? Hopefully this gives you an idea of when you say you want to focus on employee turnover, we need to be very, very specific of what that actually looks like. And why that is it's like, why should I care about this? Well, the data set that you use is the foundation for the rest of your use case. When you're going to do something like AI or data science or build a machine learning model, you're going to go through a bunch of different steps like cleaning your data, running basic charts and figures, what we call EDA, and then you're going to start modeling. If you use the data set that does not have the right sample, it's not just a matter of throwing those observations in later or kicking other people out. Like you have to start with the right group of people or you're going to have to go through that whole process of data cleaning, data exploration all over again. So please start with the right sample when you are doing data science. So how do you actually do this in practice really quickly? It starts before you even do any kind of data work. What we recommend is you need to sit down with stakeholders or whoever's involved and think through really concretely, what do I want to know from this AI project? If it's, I want to predict employee turnover, you need to talk about who qualifies as an employee. What kind of turnover are we looking at and during what time period? Having these discussions early on will save you so much time. The last thing I want to point out here is that sometimes when you have these discussions, it will involve you going back to your data and throwing out rows of data of people who shouldn't be in there. But the vast majority of time, clients have to go out and get more data to make their data set more complete. And that, as you all are probably aware, takes a lot of time. It might take bringing things into Domo. It might take compiling data sets. But if that's what it takes, that's what it takes. So in a nutshell, start out with the right rows in your data set. That is key. The second pitfall that I want to talk through is inaccurate ranges of data values in columns. And this pitfall is what it sounds like. The idea in a nutshell is that all data values in a given column should fall within a realistic and expected range. And so as a simple example, if you have a column with someone's age in it, it should be pretty obvious that none of those values should be negative, because hopefully no one has a negative age. And it probably shouldn't include many people with ages over 100. Like that's pretty straightforward, basic checking on data ranges. But there's a lot more complicated scenarios that we've noticed that clients, they don't check for. So to give an example of this, let's go back to our HR data set. And let me scroll here. Let's find a good one. Hourly rate. This column captures how much an employee is paid by hour. And if I just do a simple sort here, and let's look at like low to high, you'll notice right off the bat, I've got two rows where someone apparently makes 22 cents an hour and 97 cents an hour. It should be pretty obvious to everyone that those are wrong. Like, hopefully in America, no one is making less than $1 an hour. But if you keep going, it gets a little bit more in like a gray area. Like there's a couple employees making $8. Is that realistic? Maybe it depends on the state you live in. But I mean, if you scroll, you can see that most people are starting out above $30 an hour, which makes me think anybody who's making less than $30 an hour in this data set, like, is that right? Is that an error? That's an immediate red flag for me as a data scientist. Another example here is, let's look at the max of hourly rate. If I look at the max, I can see that some people are making $180 an hour, $130 an hour. I wish that was me. It's not. But you'll notice that most people seem to be making more than, well, at least a max of $100. So what's up with these people making $130, $180? Is that a typo? I mean, it could be realistic that there's a couple people making that kind of money. So what I'm trying to show here is sometimes it can be hard to tell what a realistic value is for a given variable. And I have clients who will tell me, who cares, Shelby? There's only like a handful here that look like maybe they're a little bit weird. The issue is that when you do data science, these, we could call them outliers. They are going to mess up every single type of statistical analysis, chart, figure, model that you are going to run. Because all of those things take into account every single data point that you give it. You can't just ignore these weird values, as we'll call them, even if there's only a handful. So the question then is, so what do I do about it? A lot of times clients are like, can I just drop them and get rid of them and pretend like they're not there? And I wish that we could, but with data science, you want to keep as many rows of data as you possibly can. So my first inclination is, first, investigate the weird looking values and try to fix them. So in my case, I might go to the HR director and I might say, you know, hey, does so-and-so really make $180 an hour? Is there an extra zero here? Like, If it's realistic, that's fine. Like if it's accurate, great. But if it's not, then you need to find out, okay, so how much are they really making and fix that. I realized that sometimes there's no way to really know. Maybe this employee's been gone for a while, so it's like, who knows how much they were making. In that case, we can try to fill in this information using like our best guess. So if we know that this person was a sales representative, swim too far. We could look at how long they'd been there and try to maybe fill it in with an average of this is how much a sales executive with that kind of experience makes. So that would be my second go-to, is fill it in with something that seems accurate based on other information that you have. As a last resort, you can talk about dropping or things like that, or leaving it blank, but don't go there as a first resort. Unfortunately, you want to put in the work to find out what is actually wrong and try to fix it. So I know that was like a lot of information and a very high level overview. I want to note that Flo or someone is going to put in the chat right now. We have 2 different data science resources about handling like extreme values and outliers, as they're sometimes called. We've got a great PowerPoint here that goes into like super interesting statistical methods for handling outliers and finding them. We've also got another data exploration PowerPoint teaching asset that talks about a little bit in more broad basic terms how you handle extreme values. So if you're interested in learning more about this, check out the link in the chat. Come find these resources. They're great. The last pitfall that I'm going to walk through before I turn it over to Flo is unaddressed missing data. And missing data is what it sounds like. It's data that is just not there. How this is actually coded in practice can look like a lot of different things. Let's see here. What do we have in this data set? So sometimes missing data is just left blank. Other times missing data can be filled in with something like NA or unknown. Sometimes you'll see like a bunch of zeros. People will just put zeros in, or like 99999. That's some of the options we see for missing data. But in general, if you have a lot of missing data, that is not a good thing. As I like to say, if your data looks like Swiss cheese, where there's a bunch of blanks or zeros everywhere, that is not good. I'll have clients tell me, well, the data that is there is accurate. Like, why is this a problem? And why this is a problem is because, in essence, you do not have a complete picture of your data. And as a result, you are giving incomplete data to your AI algorithms, to your models, and it's trying to learn things with incomplete data. Some algorithms can handle missing data, but a lot of them can't. And they'll just straight up drop rows that have any missing data at all. So for certain algorithms, if I gave it this data set, it's going to drop this row and this row and this row and this row, all of the rows with missing, and you can be left with just like a very small portion of your data if you drop all rows with no missing data. So that's why this is a problem. How you fix it, again, is going to be a little bit time consuming. Again, you cannot just drop all of the missing rows and like ignore them. We recommend, again, that you investigate and try to fill in the missing data. So to give an example of this, with this distance from home category, my first thought is like, I'm seeing quite a bit of missing here. I'm assuming most people actually have like addresses for their employees. So my first thought is like, are some of these addresses just formatted weird? So your calculation for distance from home to work isn't working? Like, if that's the case, just go fix it, and hopefully these will auto-populate. Another issue that we've seen recently is a lot more remote employees. So sometimes they won't put in anything because they work remotely. In that case, you can talk about, well, maybe we should fill it in with 0 because they're not really leaving their house. But these are just some examples of like, there's reasons for this missing data and we can handle it. Another issue could be like, when I was looking at this performance ratings by manager, I noticed that every single NA in this data set corresponds to a sales executive. So my first question to my client would be, is there a reason that none of the sales executives have performance data? Are they not participating in your performance review process? Are they using a different one? Like, are they just on a different cadence? If so, fill it in with what you do have. Maybe they're using a slightly different metric to rate performance. If they're not doing any kind of rating of performance, then you can talk about, well, how are we going to use this data? Should we just ignore performance rating? Should we not use the sales executives, etc.? But again, as a last resort, don't just drop stuff with missing data. Do your best to fill in the holes. And again, I know this is a really large topic, and I could spend 4 hours talking about how to handle missing data. So again, in this data exploration PowerPoint, there is more information about how to fill in missing data. Go check that out for more in-depth information. But just don't leave your data looking like Swiss cheese is the takeaway there. Flo, I think that's all I had to say, so I'll turn it back to you.
Great, thank you. What did we come up with yesterday for the cheese? Upgrade your cheese, right?
Upgrade your cheese.
Do better than Swiss cheese is what I'm thinking. Let me share my window. And hopefully you can see it here soon. Here we go. Oh, there's okay, here we go. So thanks, Shelby. We have 2 more items that we want to talk about. The first one is insufficient observations for segmentation. And in the context of data science, machine learning, AI, insufficient observations really refers to situations where you just don't have enough data available to either effectively train a model or even to just identify trends and patterns for your different segments. And we use the word segmentation a lot. So for those of you who are not aware, segmentation is just the process of dividing up your data into distinct groups based on specified, characteristics or features or columns. And it's very common to do. It's very common across use cases to want to segment your data because of any reason, right? In employee churn, full-time and part-time employees are clearly different, right? And the example that Shelby just showed with the positions, are managers really the same as rank and file employees? Should they be treated differently? Should you use different metrics for the 2 groups? In a marketing strategy environment, frequent buyers and occasional shoppers and, bargain hunters are very distinct groups. And for a law firm, types of cases are really important to keep in mind when you're analyzing patterns of behavior. And so segmentation is something that is very common. And let me just walk you through an example here. So we have a data set for a lender, and they want to forecast the number of applications they're going to receive for a specific group in a given month. This will help them determine, how to allocate resources and how to prioritize profitable outcomes. So the business wants to run separate forecasts, what are called segmented forecasts, and they want to run these separate forecasts using loan duration, gender, marital status, education level, credit history, property area, home ownership, and education level. So we've got a data set with 2 million rows. So this business thinks they have tons of data. And what I'm doing here is I'm just doing a massive group by of all the features or columns that the business wants to consider when segmenting the data. So loan duration, gender, marital status, education level, blah, blah, blah. And we have the total count of observations in this data set. And immediately you can see we've got some issues, right? We've got a Swiss cheese situation that needs to be addressed. We got some blanks. But even when we have data for this very first row, when loan duration is 360 months, male, married, education level 5, they don't have credit history, they own property, it's an urban area that they're applying for, and they have 2 currently open loans, we only have 1 observation, right? we can't run any sort of model with a single observation. Once we really segment by all the things that we care about or the business cares about, segmentation is not possible. And ones are pretty easy, right? A forecast is not going to run if it only has one observation in the historical data, right? But even if we have, we keep scrolling, even if we're in the low hundreds, 104 applications for this particular group over the course of 2 years, once we break this up by month, we're going to have a handful of observations. How reliable is your model going to be? And again, a forecast will tell you, or you'll be able to tell pretty easily if it looks wonky, right? But this is even more consequential for more advanced use cases, right? A forecast with a single observation will not work. A forecast with a handful of observations probably will work, but it will look funky. But without enough data, any sort of more advanced algorithm is not going to capture the complexity of the patterns in the data set, which can lead to poor model results. And that can lead to bad insights and then bad business investments. And so it's a massive snowball effect where not having enough observations is actually probably going to result in the model choosing how to group different segments together. And the model is not going to discriminate. They're going to say, well, these two kind of behave similarly. It doesn't matter what the marital status and the property ownership and the property area is for those segments. So the best thing you can do is get ahead of the segmentation problem before you feed your data into an AI tool, right? So what we would do in this scenario, if we, segment by all these features and we see that we have serious issues with the counts here, we would probably recommend, okay, which components of the segment can we drop at this point, right? Maybe they don't care that much about how many current open loans they have or whether or not they own property. And we can work our way up to segment by fewer features in order to make sure that we have sufficient data in each of those segments. There's also probably some mapping that could be done to make the segments a little bulkier. So say they are really interested in keeping all, I think it was 8 features in the segmentation. Maybe we can figure out a way to combine some of the education levels, right? Maybe the 4 and the 5 actually behave pretty similarly. And so we can combine those into 4. And that would result in a segment that's larger. That would be the recommendation here. The last item I want to talk about is unclear or unmapped data types. And this really is the process of recognizing the different types of variables that you can have in your data set, right? So you can have numerical features, you can have categorical, or you can have ordinal variables. And this is especially important to be aware of if you're leveraging a chatbot to ask questions about your data, right? You need to make sure that the chatbot or the AI can process information effectively. And for that, you need to provide enough context about the data. So sometimes, and we can look at examples here, sometimes numeric data really does represent, well, just numbers, right? Customer age, employee base pay, percent increases in customer satisfaction. Here we have loan total amount. The key identifier for numeric data is that the difference between two values is consistent across the entire range of data. So the difference between 1 and 2 is the same as the difference between 350 and 351. And then if your column is numeric, you're in a pretty good spot. It's a very good place to be. It can be bucketed in different ways, but an AI chatbot can process a numeric column pretty intuitively. You can also have ordinal columns, which is when we have categories that have a clear order. For example, survey responses ranging from strongly disagree to strongly agree, or a satisfaction score, or even education level, right? The assumption for an education column is that a higher value on a numeric scale for education level, as we have here, means that someone had more education than someone with a lower score. So even though we don't know what a 2 means specifically or what a 4 means specifically, the assumption is that a 4, the applicant with a 4 had more education than the applicant with the 2, right? And when it comes to modeling, there are advantages to treating these ordinal variables as continuous and as categories. And feature engineering can really help you determine which of those 2 routes is better, because maybe you find that the 4s and the 5s really are not that different. And so you can group those together. But what's really, really problematic actually for a chatbot is a categorical variable that is represented by numbers. And it's very common. So imagine marital status. Marital status in a column can look like, the word married or single or widowed or divorced, but it can also be represented by a number where married equals 1, single equals 2, widowed equals 3, and so on. And it's very common to input and to store and to process data in numeric form. A single value takes up a lot less memory and processing time than, a longer string. And so it's common. But in those scenarios, the chatbot doesn't know what to do with it, right? So imagine, let's look at this column for occupation. Maybe that'll be the best way to do it. Occupation is a categorical variable, but we have numeric values. So we've got 1, I think it ranges from 1 to 18. Let's see. Yeah. There is no inherent order in occupation, right? We can't say that the 18 is higher than a 1. Not with occupation, maybe with like occupation pay or whatever. But with pure occupation, these numbers are really just representing a label, whether it be, construction worker, teacher, accountant, lawyer. And if we leave occupation as a numeric value, like what we have here, a chatbot is going to do one of 2 things. The first option is that it's going to treat this column as a continuous variable and assume a linear relationship between this column and whatever outcome we're looking at. Say we're looking at the likelihood of loan approval. It's going to tell you an increase in occupation is associated with a higher likelihood of loan approval, which just doesn't make sense because we intuitively know that an 18 and a 1 it's not a scale. We can't treat it as a scale. The second option for the chatbot is that it's probably going to give you a comparison using the occupation number. So it might tell you something like the average approval rate for occupation 18 is higher than the approval rate for occupation 1. And that's just really not helpful, right? Like we want to know what the 18 means and we want to know what the 1 and the 2 mean. So what do you do when you find yourself in a situation where you have one of these columns, which again, very common? The first thing you can do is you can add labels directly to your data set, right? And that would be as simple as, using a formula tile in Magic ETL, using a case statement and saying, when it sees a 1, assign it accountant. When it sees a 2, assign it a lawyer, whatever it might be. And a chatbot can then process that information and give you responses about your data that are easier to understand, right? The other option would be to add descriptions to your data set. So in the description for the occupation column, I could add the mapping of 1 equals accountant, 2 equals lawyer. A chatbot could then take this contextual information that you're providing and incorporate it into the responses that it's giving. I personally add the labels directly to the data set because I think it also makes visualizations easier to process, right? It's hard to see a visualization that just has a bunch of numeric values at the bottom and then have to do the mental math of, okay, 18 means construction worker, 2 means lawyer. So that would be, those are really the 2 options that you've got to give the chatbot the information that it needs. I just said a lot. So, if you have any questions about any of it, please drop it in the chat. I'm going to hand it off to Christy again and actually go back to presentation. So, yeah.
Awesome, Christy. We'll bring you back in. I just wanted to say thanks, everybody, for joining. We have hundreds of people on live learning all about Domo AI, which is amazing. So we'll kick it back over to Christy to finish things up. Thanks, everybody. Again, these are long sessions, hour long, but we're doing this AI Insight series. Appreciate you joining. We're going to be sharing tons of things at the end of this. I'm trying to get this in now before it gets to the end of the hour and people are like, I got a meeting, I got to go back to work. We'll be sharing all of our checklists and some AI readiness stuff and an Insight series PDFs on LinkedIn. So make sure you're looking out for those. Christy, back to you.
Thanks, Eddie. Thank you, John, Flo, Shelby. I think one of my favorite statements has to be upgrade your cheese. Jason Altenberg, you like brie. You're in good company. I like I also, maybe you guys didn't know this, but when my son was 4, he had a Swiss cheese meltdown where he literally was whining out loud, "What Swiss cheese? You gave me Swiss cheese." I think we should record that and just play it all the time for AA readiness. Like, no Swiss cheese. So next steps, get your data cleaned up, whatever that means for you. Just take whatever step you can. The work that you're doing on this is better than no work at all. Once it is clean, certify that data set. That is going to be an important step in how AI chat and other things in Domo in the future is going to utilize your data sets. So get them certified, get a process for certification. Test out the data science tiles, check out universal models, start using Domo GPT or the AI chat version. You can get on the beta waiting list if you're interested in those. I think many of them will be rolling out this summer. And of course, sign up for a complimentary free office hour with my team, the Domo AI Labs team. You can also sign up for a free consultation with our good friend John at Dashboard Dudes. And we'll give you his information next. Thanks, everybody. If you have any questions, we're going to hang out for a bit and answer them.
Awesome. On this one, if you are interested, I have a whole course. So if you want to check it out, I have a whole course on how to use the data science tiles in the ETL, such as cluster, outliers, forecasting, all that stuff, how to use Python with some ChatGPT stuff, as well as the data science charts. You get a 14-day trial. You get access to all courses through that one too. And I would say this is, if you're interested, really like interested in this thing, the first step is, if you want to know what this data science thing is, sure, you use the tiles, all that stuff. Real data scientists though use Python. So unless you have somebody on your team who knows how to use Python, then that's cool. Then they can do some stuff. But I would say if you don't have somebody on your team, reach out to the Domo team. And if you have a chance, if you watch Shelby and Flo's presentation at Domopalooza, that was a fantastic story where they talked about the ski resort and how they're constantly having to update the model to get better and better and better every year. That'll give you just a high level understanding of what this data science thing actually mean. And last thing I'll say is, when I talk to some business people who aren't sure what data science is, they have a tendency to think, oh, we made a model, we're done. We did it. It's solved. It's now sentient. And it's like, that doesn't really work. You have to constantly adjust, and then you're like, got it. Oh, we didn't take language into account or whatever. And that it's a, like, I don't know, a 40-minute, hour-long presentation that would happen in Domopalooza. Good one to watch to get a high level view understanding of what's happening. So I'd recommend that.
Oh, we've got a question. Look at that. From X. Prior to analysts by machine learning, would it be more effective to translate relevant ordinal variables to numeric variables? Lots of big words there. Our class never went in depth with AI models, so I'd like to know the performance implications. Anything from my AI Labs team? Oh,
I can take that one.
Awesome.
It really depends. I know that's everybody's favorite answer. It depends, but it does. It depends. The more numeric you can make things, the better. Almost always, we call it interval ratio, which Flo said, like, it means that the distance between one and the next one is the same at one end of the spectrum versus the other. So, the closer you can make it to that, the better. A lot of really, really useful data just cannot be packaged that way. And so it's better to package it in ways that your business understands it the best. And I would use business understanding as a key benchmark, because if you deliver something that's perfectly perfect in the AI world, but nobody in the business can use it, it's useless. So the goal for a data scientist or or anybody else who's working in the spaces to bring those two things together and make them useful together. So that would be my general idea. But John, Shelby, Flo, you can weigh in too.
Yeah, no, I completely agree with everything you said. And I think it's very common for business users and business stakeholders to be very involved during the analysis phase and then come back after the model is complete, right? And so something that you can also do is you can transform your data to, have labels and make it easier to digest visually during the analyze phase to find patterns. And once you've engineered the features in the best way possible for your model, then you can just turn it to the numeric version for the model processing. And then once again, bring it back with some interesting labels at the end. So, yeah.
Awesome. We had a bunch of, we had a big jump in viewership. I don't know if it's Miles called all his family and said, hey, I'm on a live stream. They're talking about me. Appreciate it. It's Miles. Wish we knew your real name. I love this. Didn't know Domo started streaming here. Well, we are, and it's happening all over across social platforms. The AI Insights series with the AI Labs team every few weeks. Check your social medias, LinkedIn. It will always be Twitter to me. Twitter/X, Facebook, YouTube, wherever you spend your time watching content, we should be there. And we are going to be doing these live streams every few weeks with the AI Labs team and those friends that are hanging out in the AI space here at Domo. And it's always a pleasure to see my brother from another mother, John Lee, has way more hair than I do, and I'm always jealous.
Hair is a maternal gene.
That's why. And I got the other side.
That's why.
Awesome. I appreciate it. Thank you guys again for joining. If you have any questions, we put tons of links in the comments or chat section, wherever you're watching this piece of content. Be sure to check those out. We will catch you on the next live stream here with Domo. Thanks again to our presenters, everybody on the AI Labs team, and John Lee.
Thank you,
See
everybody.
you guys next time.
Yep.
Thank you.
Hi, everyone. Upgrade your cheese.